Welcome back. We're now going to start session 4 of the program on STEAM education in the time of COVID-19. I would like to introduce Dr. Faisal Masud. Dr. Masud is the Medical Director of Critical Care at Houston Methodist Hospital and is Vice Chair of Quality and Patient Safety, and also the Medical Director of the Cardiovascular Intensive Care Unit at the DeBakey Heart and Vascular Center. Dr. Masud.
Welcome to the Pumps and Pipes Symposium. My name is Dr. Faisal Masud, and I'm the Medical Director for Critical Care Center for Houston Methodist Hospital System. This year has been a very defining year for healthcare. We had to take care of so many patients, so many complex patients. We had to deal with a disease which humanity had not known. We had to create new ways of treating things. And one of the key things is how to be innovative, to protect our own healthcare team members, to create devices to protect ourselves, to create processes, to create equipment in taking care of those patients. This year has led us to really rethink and reevaluate every single step we have done. It has been an unbelievable year, even though a very challenging year, but a very exciting year from knowledge, innovation, technology, and breaking down barriers. I hope you will learn a lot in this symposium and you'll be able to contribute to new ways of thinking and help us creating new things. Thank you so much.
Thank you, Dr. Masud. And now a message from Dr. Bill Kline. Bill is the co-founder and director of the Pumps and Pipes program. He's been with us since the very beginning. Bill has also been heavily involved with our STEAM learning programs. Bill?
Hello, this is Bill Kline, one of the co-founders of Pumps and Pipes. I'm grateful for this opportunity to introduce the STEAM portion of the program, as now I can say that I have presented in every Pumps and Pipes conference since Pumps and Pipes 1 in 2007. This year I must participate from strict isolation because I am recovering from COVID. From firsthand experience, I can tell you that COVID is a debilitating disease, and I urge everyone to continue to be disciplined in practicing all those things we need to do to contain it. From more positive firsthand experience, I can also tell you that student participation in our Pumps and Pipes community continues to be vibrant and exciting. During the first 2 months of 2020, I was privileged to be able to interact with several Houston high schools in rolling out our Tour de Iodine and Trebuchet Challenge events, which we have every intention of resuming and expanding when face-to-face gatherings are again possible. Our online Lunch and Learn series has also been well attended, with lots of insightful questions and comments. As you will see in this next session, our students continue to model the Pumps and Pipes principles of curiosity, networking, and collaboration. I'd like to close this introduction by repeating an observation I made as a Lunch and Learn host. Students, I know that electronic screens and promises of future events are not the best way to deliver the education we promised you, for which I am so very sorry. But if there is one message that is amplified by these unfortunate times, it's this: we need you. Pumps and Pipes is about big challenges and big opportunities, and I hope you continue to trust that those opportunities will be there for you, despite the present-day setbacks. Opportunity will find you because it needs you. You are needed. Don't ever forget that.
Well, thank you, Bill. Take care and be well. This next segment are interviews of 2 students who have directly taken on the challenges of COVID-19. Anika Chebrolu is a freshman at Independence High School in Frisco, Texas. And Taft Foley III is a senior at Kincaid High School here in Houston. They will be interviewed by Annabelle, Helin, and Niels Levy-Thiebaut from DeBakey High School, who will be introduced by Principal Agnes Perry. Principal Perry?
Hello, My name is Agnes Perry. I'm the principal of Michael E. DeBakey High School for Health Professions, located in the Texas Medical Center, Houston, Texas. I would like to give you a brief background about our school if you're not familiar. Our school was developed in 1972 between a partnership between Baylor College of Medicine and Houston Independent School District. We're celebrating 48 years of existence, and we've done a pretty good job over these years. Recently, we were recognized by Children's at Risk as one of the top high schools in the Houston area. We've received this recognition for about 14 years straight. So we're very proud of the recognition. Our school was established with the intent to provide students in the Houston area with experiences in the medical field, along with hands-on experiences in the Texas Medical Center. Along with that, our students have been exposed to 5 years of math, 5 years of science, 4 years of health science, 3 years of a language other than English, and they're also required to complete 100 hours of volunteer work. So we're very proud of our students, and we welcome their participation in this activity this week. Thank you. And Annabelle, I'm going to turn it over to you.
All right. Hi, we are very, very pleased to welcome everybody here with us today. My name is Annabelle Helin, and I'm a senior at DeBakey High School for Health Professions in Houston, Texas.
And I'm Niels Levy-Thiebaut, also a senior at DeBakey High School for Health Professions. Today, we are joined by Taft Foley III and Anika Chebrolu.
Taft is a 17-year-old at Kincaid High School, and he recently became the youngest emergency medical technician, or EMT, in the state of Texas. This year, he decided to launch a mobile COVID testing lab in a van and co-founded the Texas Mobile Medical Labs.
And it is my pleasure to introduce Anika Chebrolu. Anika is a freshman at Independence High School in Frisco, Texas. This year, you won the Discovery Education Young Scientist Challenge, a nationwide science and engineering competition. Your project identified a molecule that binds to the spike protein of the COVID-19 virus, thus blocking cell infection. You isolated this lead compound from a database of almost 698 million molecules using new methods for computer-aided drug discovery. This lead compound may serve as a potential antiviral therapy for COVID-19.
So you have both achieved great things by tackling COVID-19 from different angles. Taft has approached this from testing, while Anika has focused on the therapeutic side. So, Taft, what originally inspired you to do this, or how did you get this idea?
So essentially, I saw a problem and I came up with the solution to fix it. As you mentioned earlier, I was an EMT and I attended training for that program in Corpus Christi. But when I got back to Houston, I went to a local clinic. But I was met with a line that snaked around the whole building, and I had to wait about 2 hours just to get inside and 2 weeks to get my test results back. Well, during that 2-week waiting period, I decided to go ahead and do some research. And I thought to myself, there has to be a better way. I'm sure there's a way to improve on what's going on here. And so while I was doing my research, I found Quidel's 15-minute tests, and I got the idea to put tests in a van and go to the patient instead of having the patient come to a site and wait for a really long time for a test.
Interesting. And what about you, Anika? What inspired you to do this? How did you get this idea?
A couple years ago, I was researching about the 1918 Spanish flu pandemic, and I became really interested with drug discovery, pandemics, and viruses. So from there, I did more extensive research, and I found out about the in silico methodology of drug discovery. And I was amazed at how we could use computational methods to identify potential antivirals against viruses or diseases. I started working with the influenza virus with the in silico methodology. However, with the COVID-19 pandemic, I decided to pivot and change routes and target the SARS-CoV-2 virus, because obviously that's made a larger impact than the influenza virus has done in less than a year.
And so, Taft, how did you go from idea to implementation? Did you have any mentors in this initiative?
I had a lot of help with getting this idea off the ground. The first person I went to was my father. He said he liked the idea, but he ultimately told me he was only going to help me out if I could show him that I was serious and I could help myself. He told me he was going to donate the same amount of money to my business that I myself was able to raise in about 2 to 3 months. And thankfully, he kept his word. I raised $60,000 and he matched my price for a total of $120,000. Along the way, I've had a lot of very important mentors like Dr. Joe Ibarra, who's been a massive help towards keeping my business afloat and helping me provide great care. My father is also another very important mentor. He's advised me throughout the entire process, guiding me when I've gone astray a little bit, and he's just fed me advice here and there to make sure I'm making the right choices. Both of these people and a lot of others have been willing to give me their time and their energy to help me provide the best service that I can.
That sounds super, super interesting. Anika, how did you go from idea to implementation? Like, how did you find the technologies to be able to do this? And did you have any mentors to help you along the way?
I initially started with just a couple thoughts of my idea, so it wasn't even a real idea until I did a lot more research. So that was when I could actually build the idea, build the methodology, and build the procedure, and then go through with that procedure. Unfortunately, I received a lot of help from my mentor, my 3M mentor, who was assigned to me from the 3M and Discovery Education Young Scientist Challenge. And her name was Dr. Mahfouza Ali, and she helped me gain access to many materials and many software that was needed for my project. So that really helped because a lot of software you don't get because they need academic licenses or evaluation licenses.
Taft, what challenges did you face and how did you resolve them? Were there specific laws or certifications that you had to obtain before you were able to get your mobile medical labs up and running?
In general, there's a lot of red tape I had to climb through to get the business going. But because of the pandemic, the government authorized emergency measures to address the need for COVID testing. Before I could establish the business at all, I had to apply for a state license to do the testing. That in itself was difficult because I was 17 at the time. I wasn't even an adult yet. But we hired a clinical laboratory consultant who helped us through the process of applying through the license. After that, we had to hire a doctor to serve as our medical director. Every test has to be ordered by a doctor, and our doctor signs off on these orders. Our consultant has remained on board to make sure we comply with state and federal laws and to help guide us through any red tape we might see in the foreseeable future.
All right. And what about you, Anika? What challenges did you face using this technology? Did you also find any challenges due to your young age?
The hardest part about using the in silico methodology was learning how to correlate biological concepts towards an actual software and seeing how that could best fit into what you needed. So after a lot of research, I was finally able to get comfortable with the use of softwares and learn how to best fit it for the procedure and end product that I needed. The hardest thing that was there because of my age was probably getting a hold of the softwares. Again, because of evaluation licenses or academic licenses, it's really hard to just request for them and actually get a response. So from the 3M and Discovery Education Young Scientist Challenge, I was able to get the mentors that I needed and the support that I needed to get a hold of those softwares and actually be able to use them in the time period that I could to finish my project.
I see. And so, Taft, where do you want to go from here? How do you plan to adapt your work once a vaccine is approved and distributed successfully?
Well, a vaccine is going to shorten the life of a COVID-19 testing business. Therefore, I've had to develop a business plan that allows us to expand our services and develop alternative revenue streams. I'm pleased to announce that my company has merged with a group of doctors to form a company named Texas Mobile Paramedicine Services. As a result of the merger, we'll be able to place doctors on vans who will be able to go out and offer a wide variety of healthcare services, including administering the vaccine and treating non-emergency related patients. Our business plan affords an opportunity to bring doctors to businesses and underserved communities, providing critically needed healthcare services. I believe this is the future of medicine in America. Instead of patients coming to doctors, doctors will be able to go to patients.
Wow, what an amazing idea. And so, as a fellow high school senior, I understand that you must be quite busy with college applications in addition to your work with the Texas Mobile Medical Labs. So if you don't mind telling me, what are your college plans?
Well, like you said, I'm currently in the process of applying to a large number of colleges, but no matter where my college path leads me, I hope to continue to have an impact on my community, since it's where I came from, and I always want to make sure that I give back to them. I will continue to work to address providing healthcare to underserved communities, and ultimately, I would like to be a trauma surgeon or a plastic surgeon.
Wow, it seems like you really have it all figured out. Anika, where would you like to go from here? Do you think you'll be doing research like this in the future? Is it a career path you're pursuing, or is it just a hobby for now?
Right now, I just went through the first stage of drug discovery, so there's still a long process to go that awaits. So I do plan on continuing my research. So this was just the in silico stage. So the next would be the in vitro stage and the in vivo stage, and eventually human clinical trials if it gets that far. So I do plan on continuing this research, and I do plan on going into a career in medical research.
Do you have any other big projects on the horizon? You mentioned previously that you've been working on the influenza virus. Once the COVID pandemic is over, do you think you'll be going back to the influenza virus?
Yeah, drug discovery is a long and intense and time-consuming process. So the project that I'm working on now with the SARS-CoV-2 virus is definitely going to take a while to finish and a while to determine if it's actually going to work and it's actually going to be a potent anti-coronavirus drug. And after this project, I do plan on going back to the influenza virus and working on that, because that obviously still makes an impact on the world and still needs more drugs and antivirals against it to combat those deaths that still happen because of it.
Wow, you both have done phenomenal work, and it has been an honor to speak with both of you.
Taft, is there any final words that you would like to say to everybody, especially students?
Sure. One phrase that has definitely rung true throughout my life is work conquers all, labor omnia vincit. I'm a firm believer that if you work hard enough to achieve a goal, and if you stay persistent, you're definitely going to achieve that goal. Adversity is an opportunity for change. If you come across a problem, what you need to do is adapt and work your hardest to just power through it and find a way to succeed. So my message is keep working hard, stay persistent, and you'll find your success, whatever it is you want to do.
Very well said. And what about you, Anika? Do you have any final messages for our listeners?
Yep, kind of going off what Taft said, it's really important to stay working hard and stay persistent through all the challenges, because there's always going to be challenges, but just keep your eyes on that end goal and go for any opportunity that you see, because you never know where you're going to end up, and keep on asking questions and keep your curiosity.
All right, you both have incredibly bright futures ahead of you, and it's been a pleasure speaking to both of you. Thank you very much.
Well, thank you to the entire Pumps and Pipes team and for everyone watching.
Well, we certainly wish Anika and Taft, Annabelle and Niels all the best. We've been in the studio here just marveling at these remarkable students and these interviews. It was a lot of fun putting it together. So now we have a panel, and the panel consists of Zavonia Gatson, who is the STEM instructional coordinator for Houston Independent School District, and Rustom Mody, CEO of Ventec Nanomaterials. Rustom is also one of our Pumps and Pipes directors. They will be discussing STEAM innovation initiatives and how to get involved. Rustom, Zavonia.
Well, good afternoon, everyone. Rustom, can you hear us? Okay?
Yes.
Okay. I'll let you go ahead and start us off.
Yeah, this is Rustom Mody. Dr. Stephen, thanks for introduction. I was thoroughly impressed by both Anika and that is an inspiration to the young kids and even to grown-ups. I mean, the things that you all have achieved at such a young age is truly an inspiration to a lot of people. And I've been involved in pumps and pipes, like Dr. Bill Kline and others, since it started 14 years back. And it's been really truly amazing, engagement, because not only it's about sharing your inspiration and your ideas, but also learning from each other. To me, as somebody who's been in industry for over 40 years, it's truly a learning experience. And like I always tell young kids that I interact with, learning never stops. Just because you finish high school, just before you graduated, just because you finish college, learning is a continued experience, because especially in this time and age, when things move so rapidly, if you're very comfortable in what you're doing today, you're going to be obsolete tomorrow. So just be aware of it. So the engagement with STEAM truly has been very informative for myself personally. I've been engaged in mentoring young engineers, high school students for a long time in my career. Before I became a CEO of Intech Nanomaterials, I was a VP of technology for a major all-service company called Baker Hughes. And every opportunity we got, we used to invite students from high schools, from colleges to come and visit our research labs. And what I found was when they see how engineers work in what kind of environment, including some of the kids were impressed that they were guys who actually working in a lab with coveralls and gloves and putting the tools together. It makes them really understand how technology is applied. And I think that's very critical, because kids love through interaction. You know, when they get into math and science, for them to learn earlier on how to apply that in real life really opens up their minds. And one special experience I had recently was when I was a VP of technology at Baker, was the engagement we had with a group called Force Robotics. And I actually was lucky enough to grade, judge some high school robotics project. And I found out that Force Robotics, for example, our multiple clubs, offers various kits to kids from kindergarten all the way to high school. So my message is get involved in those kind of things, especially now with COVID environment. It's very difficult for face-to-face interaction, but not only with your own kids, with your grandkids, with your neighbors' families, things like that. Encourage them to get involved in clubs like these earlier on, where you start learning how to work together as teams. To me, that's the most critical skill to have in this growing economy, is to teach kids earlier on how to work in teams, how to communicate, how to listen, how to learn from each other. And as you can see from all of our presenters today, from the experiences, it's all about learning from each other. And that's how innovation happens. Innovation doesn't happen in vacuum. It usually happens with multiple disciplines working together in teams. And that's one thing you learn very quickly of how to communicate and learn. Because individual stars are great, but in a real professional world, one has to learn the skills early on in your life, especially starting from kindergarten, middle school, you name it. Is learning how to talk, communicate, listen, and work together as teams. I cannot emphasize more than that. And the reason STEAM education provides that platform is because it helps you develop those skills early on and gets you excited in math science as a discipline, because that is one thing. It's a journey. It's like I said earlier on, you continuously keep on learning, and you develop some unique skills to analyze problems and build and relate to each other. And it's very important to apply these concepts in real worlds, because by teaching them earlier on foundational skills that are needed to really aggressively participate in this dynamic global labor market. And these skills are very important down the line. Zanavia, you got anything to add to my comments?
Yeah, I definitely echo everything that you just said. We have been using a blended learning platform here within HISD, and we've been using it for quite a while, but the blended learning platform and project-based learning incorporates the collaboration piece, the communication, finding a problem, solving a problem, reaching out to mentors to help those students engage with the industry aspect of a problem. So when we do talk about, what is education doing? How is education preparing our students? Well, our wonderful scholars from DeBakey, they're prime examples of students who are engaged and submerged in the work and able to talk with colleagues that are on the same level as them doing work that either they are currently in or they aspire to do. So, when we look at where we are in COVID, one of the challenges that we had within the department that I work in is how do we incorporate STEM when we're not face to face with our students? And I was telling my specialist, I said, hey, this is our stage. This is our platform. Like, this is what we were born to do, to solve problems. So let's put our critical thinking hats on. Let's, think outside of the box. And we were able to come up with STEM kits that we sent home. We've seen a greater increase of parent participation with students having to build their spaghetti towers or launch their rockets at home. And, parents are, why do I need to do this? Well, Mom, I need an extra hand. And so not only are we building, our students within STEM, but we're building their parents, we're building family structures. And, you mentioned earlier about our students being able to work together, to communicate, to accept challenges. I know we're in this, very strong technological world, but going back to board games, playing checkers, playing chess, these are all games that provide levels of strategy. You have to know the rules in order to be successful in the game. I taught my daughter how to play phase 10 over Thanksgiving break, and the first couple of phases, she was losing horribly, but by the time we got to phase 8 and 9, she was beating everybody. So it's all about not only teaching our children how to solve problems, but also teaching them how to lose gracefully. I know we don't want to talk about failing, but many of our greatest inventions have come out of failure. Some of our greatest innovative, projects and just successes have come out of failing. And, the one thing I always tell my specialists when they're having their STEM camps, your job is to make your kids fail every day. Why? Because there's a learning in that. We're not trying to break them down. We're trying to let them see and understand you're going to fail a lot more times than you're going to succeed. But those times that you succeed are going to be great. They're going to be monumental. So we don't want our babies to fail, whether they be at kindergarten or senior, and then just give up. Our speakers just before just said persistence, resiliency, and they just turned 18, and some of them not even 18 yet, and they understand it. So that is a message that we're definitely trying to send to our babies starting from pre-K all the way up to senior level. So when they get to college, when they get to industry, they're ready for you, Rustom. So I'm trying to make sure that our scholars are ready for industry. They're ready to collaborate and work with whoever they come in contact with. So that's all that I have from the education side. I think we're about at our time. And I just want to send a special shout out to Pumps and Pipes, Houston ISD. We've been in partnership with you all for such a long time. I think I was introduced to Pumps and Pipes back in 2013, 2014, and have enjoyed this wonderful adventure with you all. And we look forward to the continued partnership and collaboration.
I just have a closing comment to everybody listening. Be available. Make yourself available. Because the kids need people with experience to guide them and educate them. And trust me, by mentoring, you learn a lot yourself. And being available to the kids, especially right now in this tough environment we are, all we can do is be there for them and be willing to talk to them. And I just want to commend, again, the student panel that was there before us. And I think Taft and really expressed themselves very clearly. It takes courage, perseverance, commitment, and focus, because defining a problem is 80% of the solution. Just keep that in mind. It's the problems all around us. You just have to look for them, and there are solutions too, but it takes a commitment to do it. So again, thanks to Pumps and Pipes for this opportunity, and thanks Zenobia for the group.
Thank you, Rustom.
So thank you, Zenobia. Thank you, Rustom, for those words. And in particular, thank you for all that you do for Pumps and Pipes. Working together is absolutely a pleasure. Putting these programs together, the Lunch and Learns, the Tech Talks, and we'll have more of those continuing through the school year. And in fact, for those of you that want to have continue to be given information on these Lunch and Learns and other programs that are coming up, you can subscribe to our newsletter, the Pumps and Pipes newsletter, by going to the Pumps and Pipes webpage, pumpsandpipes.com. Go to the Contact Us, and you can sign up for the newsletter. Please do. And so next, I think we have some student interviews that we want to play.
My name is Vernon Mosley III, and I'm a senior at Sterling Aviation Early College High School. My virtual learning experience had its challenges in the beginning due to our key platforms, Microsoft Teams and the Hub having malfunctions. Although I prefer face-to-face, this experience has allowed me to become more comfortable with technology while gaining a new outlook on learning. Throughout this process, my teachers have been very helpful and understanding of our issues, and I feel as if we continue on this path, we will have a positive and successful year. Go Raiders!
Hello everyone, my name is Niels Levy-Thiebaut and I am a senior at DeBakey High School for Health Professions. My experience learning virtually has been a mixed one, but overall rather good. I consider myself quite lucky. My parents have been able to keep their jobs and work from home, and I have not had to seek out employment. So yes, virtual learning has been an overall good experience. The flagship science labs and shadowing experiences that DeBakey is known for have been difficult to replicate in this virtual setting, but I appreciate every effort that my teachers have made. This has been an unexpected learning experience for us all. I will admit that sleeping in has been quite nice, but I do miss seeing my friends every day in person. While I would like to experience the fun that second semester of senior year has been made out to be, I understand the situation, and I know that DeBakey will make the right decision when it comes down to it. Thank you.
All right, Lauren Ann, how is digital learning going?
I want to say it's going pretty good, but there's some bumps in the road.
Can you explain those bumps to us?
Sometimes the audio doesn't work, the video is glitchy, and sometimes our assignments are done, but we always pull through to get our learning done.
Tell me how virtual learning has been for you.
It's been great.
That's it? All right, Alicia, what about you?
Virtual learning was harder for me because I didn't. Whenever I first in 6th grade, whenever I first had to do it, I didn't know how to do it because I don't have a computer in my house, and I've never had to do something like that.
So you started off easy for you?
No.
Is it easy now?
Yeah.
What's different?
Because like, the teacher used to say, turn your homework into the hub, and I didn't know what to do. So I didn't know, so I asked my aunt, and she told me, but I still didn't get it a little bit. But then when I came to school, I got the hang of it.
Okay, awesome, thank you.
Hello, I'm Renaji Thomas. I'm the 12th grade dean of students here at Sterling Aviation Early College High School. My preference is and will always be face-to-face instruction. Nothing compares to seeing students enter the building, transition throughout the halls, or even being actively engaged in class. Virtual learning, where do I begin? It has definitely had its many ups and downs. I can honestly say that we are now on the right track and moving in the right direction. In the beginning, even our primary platforms, Microsoft Teams and the Hub, had to adjust. Our teachers are now even more comfortable and our students are even more engaged. I can now anticipate a successful 2020-2021 school year. Go Raiders!
Absolutely fantastic. I would like to give a shout out to the students there who are really letting us know their problems. And as Rustom said, 80% of the solution comes from understanding the problem there. Now, just to finish off on one of our talks tonight, you may remember back in March when the COVID was really hitting us hard, one of the biggest shortages at the time was ventilators. Okay, and I'm really pleased to know that there was a clinical instructor here, Dr. Swami, who is a renowned innovator and entrepreneur, and he stood up to that call. Okay, he went out, he formed a team, a bunch of students from Texas A&M, part of the NMED program, and they formed Third Coast Ventilator Program. Now, why Third Coast? Well, keep in mind, the Texas Medical Center is the Third Coast for medical technologies. It's no longer Boston or San Fran, East to West Coast. This is the Third Coast, and we're going to come after you, okay? So here's Dr. Swami to tell us more about Third Coast Ventilator projects.
Thank you so much, Stuart. I'm Swami. I'm a cardiothoracic surgeon at Houston Methodist and a medical device innovator. And I'd like to share with you all a little story. So, as Stuart said, back in early March, I, like many of you, watched in horror as we were running out of ventilators for COVID patients in New York and in other areas of the country. And this inspired me to start building a do-it-yourself open source ventilator that would use as many readily available parts within the hospital and off-the-shelf parts as possible. And that would be something that would be simple enough that anyone could build with minimal skill. So I started documenting my progress, or perhaps I should say lack thereof, on Facebook, and other friends and colleagues joined in. And within a few weeks, we had an early prototype built in our garage. After we hit a few design issues, we recruited students from the newly minted Texas A&M NMed program who modified, improved, and perfected it over the summer, readying it for potential patient use. So that is the story of the Third Coast Ventilator Project. And I'm going to play a little video here for our students who put this all together, who couldn't be here due to an exam. So let me share my screen.
And early in the pandemic, we were watching Governor Andrew Cuomo ask for ventilators. I thought that Tim would be able to design one. And I asked him, I said, you could build a ventilator.
So we really put our minds together. We built a prototype in our garage, and that's where the story starts.
And I started out on this project when I answered a Facebook message from Dr. Swami. He posted a ventilator idea he was doing because of the shortage. He, at that time, incorporated more knowledgeable people with technicians and doctors and engineers, some of the finest I've ever worked with, and they have developed this into a great device that we've had to, of course, graduate into microcontroller and processing. When we did that, we pulled in some amazing students from the local colleges that were able to really take charge in this and develop the ventilator into a beautiful device that is able to help save lives around the world.
From the garage, now the Third Coast Ventilator Project is on its way to the hospital setting to save lives. Let's look at this video to see how it exactly works.
So we initially created a very simple ventilator consisting of a modified Arduino microcontroller, a hospital issue rotometer, 2 solenoid valves, and a modified respiratory circuit. So the controller initiates the action by opening the inspiratory solenoid valve that's here in green and closing the expiratory solenoid valve that's here in red. The air and the oxygen then basically goes into this modified respiratory circuit. The patient can take a breath in as a tidal volume, and any excess air that's pressurized can be released through this limb, which is the PIP limb, or the positive inspiratory pressure limb. When it's time for exhalation, the controller basically just turns the inspiratory valve off and turns the expiratory valve on, and air can egress through this expiratory limb or through the PIP limb. There's also a feature for spontaneous breathing. So there's a rescue airway limb that allows for that. Air can come in this way, go into the patient, and again, excess air can egress via this limb or the expiratory limb. The device thus allows for pressure-regulated, volume or flow-controlled ventilation and will meet the ventilator needs of about 80 to 90% of COVID patients. It only has a few moving parts, and most of the patient contacting parts are already FDA-approved parts that are present within existing respiratory circuits. The initial prototype was promising, but it had some problems, and that's when the Texas A&M NMed students came in and saved the day.
Dr. Swami reached out to the NMed program for help on the ventilator project. The NMed program offers engineers a medical degree in hopes to spark innovation in the field. Third Coast Ventilators allowed us a unique out-of-classroom experience in medical device design that highlighted the integrated nature of NMed. While learning about the pulmonary system, we were able to incorporate engineering lectures for a real-world application. When we joined the team, they needed help with the computer science and electrical engineering aspects of the project. They were having trouble getting the exact timing for opening and closing of the solenoid valves. And this is important to ensure that we can get the predicted tidal volumes and that there isn't pressure buildup in the system.
So one addition that the InMed engineers made to the overall project was we put in a pressure regulator valve that is able to hold the whole pressure of the system below half a psi, which is really important because we don't want to overpressure the system. And this happens as soon as air comes off the wall before it passes through the first inspiratory valve.
In addition to optimizing the inspiratory-expiratory valve timing, we're able to adjust the inspiratory-expiratory ratios ranging from 2:1 to 1:4. With digital input, we can tell the ventilator exactly how much volume to deliver to the patient. We can do so with very high accuracy, and we can deliver tidal volumes ranging from 200 to 1,000 milliliters. With our addition of a simple water bucket, we can control peak inspiratory pressure. This allows us to not overpressurize the lung. We can fill the water bucket up to 30 centimeters of water. Downstream from the lung, we can control positive and expiratory pressure. We can control these pressures between 1.5 and 20 centimeters of water, and this allows us to keep a baseline pressure within the lung so the lung does not collapse on expiration. Our design allows us to digitally control respiratory rate, which has been tested from 12 to 30 breaths per minute. A recent improvement to our design is a 3D printed compact box. This box has an LED screen mounted to the top and wires connected to the Arduino from the LED screen. We also have holes in the box that allows us to run tubing through, and the solenoid valves are housed within the box.
The ventilator industry could not keep up with the increased demand for ventilators, in part because most companies use the same manufacturer for parts. Given this, we wanted to build a ventilator out of parts that were not part of the normal supply chain and that would be readily accessible in most hospitals. Cost was another constraint. The average ICU ventilator can cost up to $30,000. In order to make a ventilator that was accessible, we knew we had to make something much cheaper.
The total cost of the components is currently under $1,500, and our aim for the device is to help COVID-19 patients in mild to moderate respiratory distress and free up ICU ventilators for use in patients with more severe ventilatory requirements like acute respiratory distress syndrome or ARDS.
From really the moment that Third Coast was pitched to us at InMed, I could see that this project was one with significant potential. Taking something as complicated and expensive as a ventilator and flipping it open source at 1/100th of the cost is just enough to make any engineer feel incredibly fulfilled. And it's been a real pleasure to work on this project.
Now that our design has been validated, we are excited to move forward with our product and work to publicize the Third Coast Ventilator project. Our team is currently working to develop alternate configurations of the device, including one which is capable of automatically altering the flow rate based on the physician's desired inputs, and another which can monitor the machine's outputs to the patient and automatically make adjustments to ensure consistency. Our ultimate vision is to have a variety of ventilator models which can be assembled by users at any skill level and regardless of budget. We wanted to utilize parts which were easily sourced and allow users to determine which model would be the best for their practice. Our designs do not require access to a lot of expensive fabrication equipment, such as 3D printers and PCB milling devices, because we didn't want to exclude a significant proportion of potential users who are not at large academic centers. We envision our product being used by anyone who is in need of an easily built, low-cost, robust ventilating system.
Our ventilator design is available on our website, thirdcoastventilatorproject.com. There you'll find a parts list, assembly instructions, instructional videos, and device specifications. Our device design and corresponding microcontroller computer program is accessible and available via an open source repository, also found on our website. And it's our hope that our progress will be able to contribute to helping patients with COVID-19.
So as you've seen in the video, we've been able to make a highly capable ventilator device at a fraction of the cost of existing ICU ventilators. And we're exploring whether or not there's a potential business opportunity here to develop a disposable or nearly disposable ICU-capable ventilator device that can function as a ventilator, a CPAP, a BiPAP device, and disrupt the current capital equipment model that dominates the market today. And we're looking into potentially developing a startup medical device company around that concept. So please come check out our website, check out our breakout room during the afternoon session. We're looking for collaborators on all of this, and thank you so much for your time.
That was absolutely incredible. It's a really humbling experience to see a project like this go from concept to reality. And again, Swami, I just want to thank you for essentially mobilising an MMed army to create this on, and you've done it exceptionally well, so thank you very much. As we now are closing out, I actually believe ahead of schedule. I'm not sure if this has ever happened, right?
No, it's all time first.
I'm going to hand it over to Dr. Lumsden to just give praise, give thanks, and to send us on our way.
Yeah, thanks, Stuart. And, my thanks primarily to you and Steve for putting this together. But there are so many people who help put this together, and our video production team behind the scenes here is another army of people who've managed to pull this off. I can tell you, we entered today with a certain angst about how well this was going to be. You've certainly put that angst to bed, and you've done a tremendous team. But there's so many people who participate in Pumps and Pipes. Our shout out really for Bill Kline. This is the first year he's not been here. We know he's been sick. We look forward to getting him back on the stage next year. So haste ye back, as they say in Scotland. Other things that I always go back to, we call this a uniquely Houston opportunity, this interface that occurs between medicine, aerospace, and the energy business. And we really think it's about getting in front of engineers. Engineers solve our problems. We can sometimes identify them, but it's the engineers who solve our problems. And that's really what NMed is all about. It's bringing engineers into medicine. And so please look at their breakout scheme this afternoon. Last thing is, the word we often haven't said it today yet, Steve, is the other guys or gals toolkit. I honestly believe that the big leapfrog opportunities are when we stare into somebody else's toolkit. I really don't learn that much from vascular surgeons anymore, but whenever I can go into the operating room or the interventional suite of another specialty, or even more exciting is to get into the research labs, at Halliburton's or ExxonMobil when Bill was over there. It was just incredibly exciting for us because we all work in fluid dynamics, we all work in robotics, and it's a matter of seeing what those applications can actually be. So thank you all for participating. I'm going to hand it over to Stuart, who's going to tell you a little bit about the logistics for the afternoon session. And I think he's got a special surprise for you before you even get to that.
Yep, always have a special surprise here. So on that note, I'd like to close it off, and we have a very special gift. We have the Healthy Highlander, who is otherwise known as Mark Morrison, CEO and founder of Invigorate Coaching. He has put together a workout session for us. You got to keep healthy at this time, okay? We've all been sitting down for almost 4 hours, so get up off your seat if you're feeling fit and work out with a Healthy Highlander. Thank you very much.
I help overwhelmed professionals over 30 who are frustrated with their weight, shed the weight, rock their business and feel better about themselves. My name is Mark Morrison of Invigorate Coaching. I'm much more than just a personal trainer. I'm an exercise physiologist and a certified health and life coach. I'm a results-driven, high-performance coach. And that is why they call me the Healthy Highlander. Welcome to Pumps and Pipes 2020. This is the Healthy Highlander here, and I'm here to get you warmed up and get the blood pumping through those pipes. So stand up out of your seat, your chair, shake it off, okay? And we're going to do 4 minutes of exercises. We're going to start with 30 seconds of marching in 3, 2, 1, go. Let's march it out. Come on. That's it, you can do it. Swing those arms. We've been sitting too long. We need to shake it off and get the blood pumping. All right, next one, get ready to do lunges. 3, 2, 1. Okay, lunge, alternate legs. Lunge. Keep switching legs each time. There we go. You guys are doing great. Stay with me. All right, in 3, 2, 1, we're going to do squats now. Okay, get into the squat position. Bend those knees. Stick your butt out. Keep your chest up. Back straight. Bend those knees. Squat down. That's it. 30 seconds of squats. Okay, let's see how low you can go. All right, get ready for leg curls next. 2, 1, okay, leg curls. Whew. Bend those knees. Bring your arms into play. Let's get the blood pumping through those pipes. Let's get your heart pumping. You guys are doing great. All right, in 3, 2, 1. Okay, reach across. Really stretch. Bring those arms across and tap your toes. All right. 30 seconds of this. And then get ready to bring your arms up over your shoulders. And 3, 2, 1. Okay, arms up. Bring those arms up. There we go. We're almost there, guys. How you feeling? All right. Hang in there. Get ready to do push-ups in 3, 2, 1. Okay, down into the push-up position. And go. You can do modified if you need to. Just do what you can. Okay, get ready for the plank. 3, 2, 1. Plank position. Okay. Nice straight body. Tight core. I don't want to see any sagging or any raised butts. Keep your body nice and flat. We're almost there, guys. Hold it. Hold it. 3, 2, 1, and relax. Great job, guys. I'm proud of you. So the reason I'm wearing the kilt is, number one, I'm Scottish, and originally we had planned to climb a Munro, so I was going to do 800 and something flights of stairs to climb a Munro, but we're doing this instead, and I hope it got the blood pumping through those pipes and woke you up, gave you some energy. I actually bought this kilt in my early 20s. I'm now 42 and I can still fit into it. So I encourage you all to stay fit, stay healthy, and keep moving, keep active. Again, Healthy Highlander of Invigorate Coaching. Enjoy the rest of the event. Bye.